Yeah. So good morning, everyone, once again. So today we are going to start SAP HANA administration part. It's like HANA is a database administration, right? So during the demo, we discussed about just a small introduction, what is HANA. So today we'll continue with this some introduction about the HANA and what we required, like in the sense requirement like hardware requirements and software requirements to install the HANA database. So why HANA is very fast nowadays? All customers are implementing HANA for their databases. So why it's so important? So that those things we will discuss today. Okay. So first of all, HANA. So what is HANA? What is HANA? So HANA is one of the in-memory database platform. What is mean by in-memory? So HANA is in-memory database platform. So in-memory means RAM memory, physical memory, right? In your mobile phones, laptops, you have the memories, RAM, right? Physical RAM slots. So that is the RAM memory. That is called the in-memory. So HANA, it will store the data in memory, not in the disk. So what does it mean by data storing in RAM memory? What is mean by disk? Okay, let me take the example here. Okay, we will understand. So in HANA, okay, let me type the abbreviation here. Okay, so HANA means high analytical, high analytical. So high analytical. So high performance analytical appliance. Okay, appliance, high performance analytical appliance. So this is the abbreviation of the HANA. Okay, so high, so ANU. Okay, so HANA, this is the high performance analytical appliance. This is the HANA. High performance, the performance is very fast. Very fast means within fraction of milliseconds you will get the data from the database. Within fraction of milliseconds, that's the performance of the HANA database. It's not like that other databases. So HANA, so it's not like that other database. Other database will store the data in RAM memory, but not like that. So other databases. So normally, so when we request, normally how the request flows. So if you see here, CPU, memory, disk. Okay, CPU, memory, disk. Okay, so CPU, this is the CPU. So this is the memory. So this is the disk storage. This is the disk storage. CPU, memory, disk storage. So whenever user requests anything, first of all, any database, first of all, it will go to the CPU. Then it will go to the memory. Then it will go to the disk. So like that, it will go to the navigation. This is the navigation will happen. First, it will go to the CPU. Then CPU will hand over the request to the memory. Then memory will go to the disk level. And the disk level means our C drives, D drives, drives are there, right? Drives, disk storage. So those are the drives. It will go and search in the databases. So same as like in how, suppose if you take here we have the SQL server as well, right? In the SQL server, we have SQL server databases. So these are the data files created. Whatever we are working in the front end, so in the front end means in the SAP screen, in the back end, it's storing data in the data files. In the data files, it is storing the data files, right? We cannot read directly from here. So only SAP can read the data from here. So which means it is storing the data in the disk storage level, C drive or D drive, it is storing the data. So same as like other databases as well. Other database also, it will store the database into, so here, right? So other databases, it will store the database here. But initial request comes from CPU, then it will go to the memory, then it will go to the disk, then it will search the data, your request from here, then it will give back to the again here, then again here to here, again it will give the request to the user. Here user is available here. Here user is available here. It will give the request to the user. So that's the thing will happen in other databases. So other databases in the sense like, so we have SQL server. So we have SQL server and Oracle, DB2, MaxDB. So other non-HANA databases, non-HANA databases. So it is a time-consuming activity. It will take some time to fetch the data from the disk storage, then hand over into here. Why? Because user is sitting here in front of the computer. Then whenever he wants to some records, it will go to the CPU, memory, disk, then again giving back to the user. Means it is taking some time. It is taking some time to fetching the data and giving the records back to the user, right? So this will taking some time to giving the data, but to avoid these timelines, why? Because so if the one request also same request, hundreds of requests also same request means, so the user cannot wait with that patience. That patience cannot wait, right? So he will go to the another site and he will book the tickets, or he will book the tickets and he will do whatever, he will book the order, whatever he want he is doing, he will book everything, right? So same as like that. So to avoid this type of slowness issues, not the slowness, fetching the records very slow, to get the very fast, HANA implemented the one technology that is called the in-memory technology. In-memory technology, they have implemented the one of the innovation. Innovation means one of the new feature they have brought into the market. That feature has live and it has been successfully implementing by all other customers. So what is that future? What's new in HANA database compared to the other databases? What's the that new feature in HANA database? Okay, so if you see here, we have CPU, right? Same as like here, here we have memory, CPU and memory. So we are calling HANA as in-memory database. Means, so they have removed this disk and they have keep it into the in memory only, which means CPU, and this is the memory, and this is the disk. This is the disk we have, memory and disk we have, memory and disk storage we have here in the here. Okay, so whenever user requests any data, it will go to the CPU, then it will go to the memory. So in the memory itself, we have data, then it will check data here, then the response giving back to the user. So we are saving this much of time going to the disk, checking in the disk, giving back to memory, storing into the memory, and it's going to the again user. So we are saving this much of data, this much of timelines we are saving here in the HANA database. HANA database, we are saving this much of data. So they have CPU, memory, data storing activity, but data storing activity not in the separately. Data storing activity inside of the memory only. Inside of the memory only, the data is residing. The data is sitting. Data is storing here. Inside of the memory only, the data is storing here. So that's why it's a very fast. It's a very fast. This is the very activity. So there is a one statement, storing the data in memory is 1 lakh times faster than disk. You got it right? So storing the data in memory is 1 lakh times faster than disk, which means it's a very fast. It's a very fast, 1 lakh times very fast to get the data from the main memory. To get the data from the disk, it will take time, but to get the data from the main memory, RAM memory, it's a very fast activity. Let me show you one example. So it's not the example, it's not related example, but I will show you how it will take to get the data from database level. Suppose I am using one just like that. I am using one word to get the data from my disk storage, C drive or D drive. See how much time it is searching now. It is searching. It is searching the results in the database. See here, it is still searching. Still, I have not get the results here. So I need to wait. So it's keep on loading. It's loading. So still I have not received any data. Just like one keyword I searched here to get the data from. So my disk storage. Disk storage means so my C drive or D drive, whatever the drives are there. So it is searching. Still it is searching. I have not received the results. See here how much time it is taking. But if it is the HANA database, you want to some data to fetch it out. Fetching means you want to see the data. Immediately you will get the data within fraction of milliseconds. Why? Because what is the new feature? It is SAP implemented in-memory database feature, which means in-memory database feature. So data storing into memory, in memory means so data storing into the not the disk level. In one step before only data is storing into the in memory. So in the there is a one more Intel hardware, Intel team, Intel company. So they are doing some plannings to store the data in CPUs only. CPU sockets, right? CPU only they are storing the data. So but it's not planned. That is the one of the new ID enhancements they are planning to do. Why? Because so one step before only SAP innovated, think, and they have introduced the HANA database. So, and before memory, there is a CPU, right? So they are planning to store the data in CPU itself, So that is the innovation they are planning to do, but still they're still in the planning phase only, testing phase only. I don't have much details, but still they are planning to do in the here itself, not in the main memory, not in the disk storage level. So that is what the new innovation is going to happen in the so for that company. So it's the thing of the so CPU and memory disk. This will happen when you want to search it new thing. This will happen. It will go into disk storage level. It will search down. Suppose if it is the HANA database, if you have implemented, then it is very fast. Within fraction of milliseconds, you will get the results, right? I will show you how fast it is. Why? Because so SAP HANA recent one of the central government, right? IRCTC, this HANA database, our IRCTC company, our Indian Railway Ticketing System is using the IRCTC, they are using this IRCTC to for this ticket booking for their day-to-day operations, everything. This ticket is booking. IRCTC is helping our HANA database. They are storing the data, everything into the our HANA database only. See here per day how many tickets they are booking daily. So everything, so they are storing into the because of the SAP and their HANA database. Okay, so if you see here how fast we will get the results from the HANA database. If I go here, so if we go here, so I want to book the ticket, I want to search here, just click on the refresh button, then immediately you got the results here. Just click on the refresh button, immediately you got the results here. Immediately, within fraction of milliseconds, you got the results here. So how fast it is? It is getting the data from the database and it is showing the results here. How fast? Why? Because it's the back end, they have implemented the HANA database. That's why you can see very fast you are getting the data. Previously, there's a different SAP, there is a different IRCTC screen, and it's very slow. It's very slow previously, right? Previously, if you use 10 years back IRCTC or 10 years back IRCTC, it's a very slow applications. If you book one ticket, you need you are lucky, you are luckiest person who doing that day. So because you will book the ticket means it's great. So but nowadays even our mobile phone also we are booking the tickets. Okay, so that's what we are doing here. So that is what HANA database. Immediately within a fraction of milliseconds, you will get the result. But here, see, still you have not get the results here. It is taking some time. It's taking some time. Why? Because it's storing the data into the disk storage level. Disk storage level, it is storing the data. Storing the data into disk storage level. So that is the thing will happen in the in the when the data is storing into the disk storage. Okay, so let's talk about directly talk about the our HANA database, what we required here. What are the advantages we have for storing the HANA database? So in HANA database is column is HANA database. So if I talk about the high performance analytical appliance, it has only columns. Okay, it has only columns and column oriented database and columnar tables. Column oriented. Okay, column oriented and a columnar database. It has only columns. So previously, when we see for other databases, it has only rows and columns. Each table they have actually data storing into the database in the form of tables and tables, right? In the database, suppose this is a one of the larger database. Okay, any database. So we have number of tables in the each database, right? Each data employment table, students table, so some other bank accounts table, credit card tables. So every lakhs of tables are available in the database level. Each table has columns, rows, and columns also available. Columns also available. Rows, columns, rows, columns available. Each table they have. That is, this is the database. This is the database container. So in the database container, we have number of tables are there. So number of tables are there. In the table, data will be storing it here. Data is storing it here. Same as like in the HANA database also, data is storing. Data is storing in the form of tables only, but it has only columns only. It has only columns. It has only columns only, column store only. That's why HANA database is called the columnar database. Columnar database. So column store tables are available. That's why it has only columnar. So columnar database, column oriented columnar database. HANA is a in memory. You can say abbreviation like HANA database is a in memory column oriented columnar database. Okay, it's the one of the fastest columnar database. It has why? Because it's storing the data in the form of columns only, not the rows, not the rows and column. It will store the data into the columns only. In the columns only, it is storing the data. Okay, so column based storage that has only column storage. In the columns only means so only columns we have. Only columns we have. Only columns we have, not the rows. That's why it will use the why it is very fast means it will use the linear search method. That is called the linear search method. Linear search method. It is one of the, it will use the linear search method to get the data from the HANA database. Linear search method. Why it is very fast means it is the in memory column oriented columnar database, and HANA uses the linear search method to pull the data from the database, which means so it has only columns. It has only columns. So which means so columnar wise, like let me draw one more diagram. So now database we have drawn. Now this is the table. Okay, this is the table. You know, right? Tables. Like in education, during your education, you have the DBMS topic. There is a DBMS topic. In the DBMS topic, might you have so discuss you have read about so columns and rows, tables, and everything, right? So here we have columns. Suppose country. Suppose if I take the columns, how the data stored into the country here. Country means all the countries will come here. US, so US, so US and JP, so and India. So all the countries will come here. Then immediately next column, all US related data will be stored. All the countries related data stored into in this column, right? The product. So product means suppose what product they are selling, alpha, beta, something like that. We can use some products. What are the products they have? So suppose like we can say example alpha and beta, so something gamma, some just example I'm giving. So just example I'm giving to put the data into the columnar format. Sales, what are the sales they have? Sales. So sales means what is the amount pricing? Maybe 3,000. So maybe so 1,200, maybe 700. So like that, I put the some tables. So in this HANA database, tables are oriented in the columnar up. So the data which are storing into the columnar way, they are optimized for the high performance. So for reading the data right? But searches also, if you want to search something, immediately it will go and search the data from the database in the tables, columnar tables only. Okay, so this means so data typically the columnar, the calculations are typically executed in the small number of columns. The table is searched based upon the value. So based upon the value, the table, the suppose the country is equal to US, I want to data means immediately it will search it here. Then it will search the data from the US related product and sales. Immediately it will search it out. Okay, the table has large number of so rows and the columnar operations are required. Okay, if the table has large number of rows, definitely we have to split the table. In HANA, there the high compression rates as well. Each table there is a one compression technique will be used, and also the linear search method, compression technique and linear search method. I know like you will get digest all these things, but you have to remember all this the linear search method. Okay, it will use the linear search method and columnar database and column oriented columnar database, and it has only column tables and column. So when you are speaking to someone on a database, so in your mind, so in your words, you have to speak about only columns. Column oriented columnar database. It has only data storing into the columnar way. Okay, it will use the linear search method for fast access, for speed accessing, for getting the speed, that much of speed. So if you talk about the advantages, so if I talk about the advantages, data will be compressed. Data will be compressed in HANA databases. Data will be compressed in the HANA databases, and also on fly, we can make the business decision. We can make, suppose so you want history of the last 10 years, your product history, your sales history, you want to see. Then within fraction of seconds, you will get the history of the your product. Then you can release the new product as well. You can release the, suppose to any person, business person, they want to salesperson, they want to release their product to the market. First of all, they will check their history, like how much data, like they check the history in the past 10 years, past 5 years, like past 10 months, the history they will check it out. How was the so sales in that months? Based on that, you can make the business decision and you can release it. But in HANA, within fraction of milliseconds, you will get the data from the database. Then you can release the new product. That's the history also. It make it history also. We can check it out. Okay, so that's the HANA database, right? So compressed mechanism. So it will compress. It will use the 10x compression technique. It will use the 10x compression technique. So which means you have suppose 100 GB of data is storing into the database level, almost will use the 10x compression techniques, which will compress the data, then will store the data into memory. So maybe 100 GB, 100 GB will not be stored. Maybe it will store the 60 GB, 50 GB data will be stored into the database. Why? Because it will be compressed. Compression mechanism will happen. Compression means so zipping mechanism. In our words, we will talk it as the zipping. Suppose if you have one folder, suppose we see here, this is the folder. This is the one of the folder we have. So suppose this is the one of the folder we have. It is called the 14.5 MB. If you compress it, what will happen? Compress means if you zip it, it will reduce the space, right? It will reduce the space. So which means, see here, it is reduced 13.6. It reduced the data. So 13.6, 14 to 13.6, it is reduced the data. So which means it's compressed. Data is compressed means, so you will reduce the data. You will reduce the memory. Memory will be, the space will be reduced. So here data is storing into the RAM memory, which means we need more RAMs we required, more RAM size we required, to get. Why? Because all the data storing into the RAM memory, which means we need the more RAMs we required, more physical memory we required to store our business data. So that is the only thing we required for the HANA database. More RAM is required. So that's why we cannot install or practice, or we cannot store our business data in the smaller RAMs. So it's a minimum GB of RAMs are required. How much minimum we required means that we will discuss now. How much is required now? Okay. So now understand, right? What is HANA means? HANA is in-memory database, column-oriented, columnar database. It has only columns in the columnar tables. Okay. When you are speaking to someone, or when you are informing, when you are explaining to someone, then in your words, it has only columns, columnar words, column-oriented database. It will use the linear search method and compression techniques, 10x compression technique, which means data will be compressed in the HANA. Data will be compressed in the HANA database. Okay, that is what we'll do in the HANA database. Okay, so now to install the HANA database. Okay, now we know like what is HANA. So why it is so important in the nowadays, why all customers are using means it's a very speed. Because of the speed, all customers are using this HANA database in their business. They are using this HANA database to store their business data, live data, analytical data. They are using it. Okay, so and also one more advantage, we can also store the live data and analytical data. What is mean by live data? Suppose if you do transactions here, that is the live data. Analytical data means the transaction is old, the transaction is so past, then that is the old data. So last 10 years historical data also we can store in the one HANA database. In one HANA database, we can store the live data and transactional data, OLAP and OLTP transaction. We can store it in one HANA database. We can store it. Okay. So what we required to install the HANA database? Okay. What we required? So we know, like we already discussed. So requirements to install the HANA database, what we required. So HANA. So what we required? HANA hardware requirements, and what requirements we required? Hardware and softwares, right? So now we will discuss about the hardware, what we required to install the HANA database, right? To install the SAP, what you required? You need the space, file system, RAM, right? So operating systems. So then, so softwares we required. This much of network, everything we required to install the SAP application. But this is the database, and this is the HANA database. Especially for the HANA database, we need to be careful when we are doing the sizing of the HANA database, and we are checking these things, what we required here. So for HANA database, hardware requirement, definitely they may ask you questions. So what is the OS? Here we should discuss about the OS, and what is the OS we required, how much RAM we required, how many CPUs we required, then how many, so space or file storage. We will normally we will discuss as the storage, how much storage we required. So, and network, what is the network here we required, the network, how much network we required. So these all are comes under the hardware requirements. This all are comes under the hardware requirements, right? What are the, so storage so required, and CPU, RAM, memory. So RAM means memory. So OS. So what is the OS we required here? What is the OS we required? Here we required only, means HANA we cannot install on the, so Windows platform. Windows operating system we cannot install. Why? Because so it's a RAM requirement. Depends upon the Windows cannot support that much of RAM. That's why we cannot install on the, so Windows operating systems. So, but what we required here? So HANA we have to install only on, so only on SUSE Linux operating system, which means Linux operating system you required. Linux operating systems you required. So Linux operating system, in the Linux operating systems we have to install in the OS. So OS is for HANA, the OS is required the only Linux operating systems, which is opposite to the Windows. It's not like that. So Windows we can log in through MSTSC, then we can just click on the next button. So just we can click on the working on this one. It's like, so if to log into the here, you need the, so Putty. Putty is the one of the software you required here to log into the Linux operating systems, right? Then you can log into the Linux. Linux means it's a command prompt based. So here it is only, so black screen. It has only black screen. Here you need to enter the passwords here. Here you need to enter the passwords, and you need to execute the commands to get the results here. So to get the results here. So this operating system only HANA will be installed. You cannot install on the Windows operating systems. That is the very important point you need to remember, right? Okay, you need to remember this important point you need to remember. It's a very important point you need to remember. You can only install on the SUSE Linux operating system only. So I will explain how to log into our Linux operating systems, how to do which commands we need to practice, that everything we will discuss. Okay, don't worry. And RAM. So RAM size requirements. So how much RAM we required, since we are using the HANA database for our business. Our business we are using the HANA database. How much RAM we required? How much RAM we required? So RAM size we can scale. Scale means we can calculate two ways. One is the, so two ways we can calculate it. One is the, so quick sizer tool. Quick sizer tool. Second one is the t-shirt sizing. Okay, some people they will use the t-shirt sizing method. T-shirt sizing method they will use it. So what do you mean by quick sizer tool? Quick sizer tool is the one of the SAP provided this tool to us to estimate the RAM size, how much RAM we required to estimate this RAM size. So to estimate this RAM size, so we have to use two methods. We can use it. Either you want to go quick sizer tool method, or you want to go the t-shirt sizing method. Okay, either whatever you want. So quick sizer tool method means it's a just a browser level one URL to get the, so to get the link. Quick sizer tool. See here, SAP quick sizer tool. So using this tool, we can calculate the how many CPUs we required, how much disk we required, how much RAM we required, memory. RAM means memory, CPU, disk, and IO network, how much we required. All these things we can calculate it. Okay, so quick sizer tool. Using the quick sizer tool, we can calculate this one. These are the sizing methods actually. So we can go deeply. So how to calculate everything, we can calculate it. So we can calculate this one. So HANA based, so quick sizer tool. Okay, we can go to the quick sizer tool here. In the quick sizer tool, so in the quick sizer tool, we can So calculate the RAM size and everything. We can calculate it. Let me take. There's a URL which provided by SAP. So overall, the main aim of this Pixizer tool is to calculate the RAM size, how much RAM we required. So how to calculate the RAM size means it's based on, so based upon the your data, how much data storing in 5 years, how much data is storing into the system. So how much data storing into the your HANA database in the form of tables. So in the next 5 years, we will do the calculations based upon how many users, how many concurrent users. So, and also how many users they are storing the data, how much data they are storing, like that. So, like that, we will calculate the sizing here. Like that, we will calculate the, so we will calculate the sizing here. See here, here already, so the customers already done the sizing here. So based on that, we will get the estimation. Based on that, we will get the estimation of the each and everything. We will get the estimation. Then how much RAM we required. Sizing. This case is for the purely sizing. This is for the purely sizing reports. Okay. This is purely for sizing report. We can take it one thing. So then we can we can display it. Then we will get the how much RAM we required. So based on the calculations, we will get it out. How much RAM, memory, we will get it out. So all these things we will get it from here. So all these things we will get it out from here. So here what we required is, so here we need to get the functional people, like functional work, like how many users will log in per day. So how many users will log in per day. So like that, we have to calculate it, how many objects. So normally, the sizing report will be performed by, the sizing will be performed by the architects or senior people in your organization, they will perform it. So they will use this tool to calculate how many CPUs, memory, and disk requirements they will get it out. Okay. This is a web-based tool. It is available all the days, all the hours it is available. So basically using this tool, you can find out how much RAM. So you can see here, there is a few snapshots, how much RAM we required, how much memory we required. So how much memory we required and how many CPUs we required. So we will get the report, we will get the information from the, so this quick sizer tool, If we calculate this one, we can calculate it, but we need some inputs like data, functional data inputs we required here. Like data means they know how much data will store in the database level in the next 5 years, how many users they will log in, they know each and everything. So we need inputs from them. So we have here, we have already in the blog is available here in this blog. So we have already some screenshots, how much data we required and CPUs, memory, how much it is required. So we can get it out. We can see how we got the results and everything, how many CPUs, memory, how much memory we required. So we got it everything here. Based on that, we will find out the information from the, so here we need to get the, so we need to get the here information here. We need to create the new project. Then we have to fill the inputs and everything. Then when we calculate it, you will get the estimation of the RAM size and everything. That is for the tick sizer tool. Okay, that is for the tick sizer tool. The next one is the t-shirt sizing method. So t-shirt sizing method means, so suppose our t-shirts like small, medium, so large, so extra large, right? Based on that, for small size company, if a company is the small size company, then minimum 128 GB RAM is required for the HANA database, minimum 128 GB. Is a medium size company, then you need 256 GB RAM is required here. Is a large size company, you need, so 512 GB RAM is required here. Then extra large, you need 1 terabyte minimum is required here. Minimum RAM. This is the minimum RAM requirement is required. Why? Because based upon your company size, you have to calculate the RAM requirement. You have to calculate it based upon the company size. You have to calculate it. It's a small size company, then minimum 128 GB RAM is required. Medium 256. Suppose small size company, I will use the 500 GB mean that is fine. Minimum is 128 GB. So if we are using above, then that is fine. So only with small size companies, we have to use this one. We have to follow the t-shirt sizing. Like when you go to the shopping mall, you will get the size, right? Small or medium or large. Same as like there is a one more approach called the t-shirt sizing method. So using this method, we have to calculate the how much RAM we required for the HANA databases. So these inputs we have to give it. This is straightforward. So if it is a medium size company, then you can go with the 256 GB RAM. It is a large size company, then you can go with the 512 GB RAM. So RAM requirements. So based upon the RAM, you will get the how many CPU estimation you will get it out. So based upon the RAM, you will get the CPU estimation. So these requirements are very important. So they will ask you questions like during the interview. So can you explain HANA pre-steps like hardware requirements and software? To install the HANA, what you required? We need to take care of the hardware requirements and software requirements. So hardware requirements, OS and RAM, CPU, storage, network. So these are the things we have to consider as part of the hardware requirements. So how can we get the RAM size? We can use two ways, quick sizer tool or t-shirt sizing method. So quick sizer tool is the web-based tool, SAP tool. So then we can fill the inputs in the quick sizer tool. Then we will get the estimation RAM size and CPU and storage, we will get it out. So t-shirt sizing method also one of the straightforward method. Then we will get the how much RAM is required for the medium size companies and large size companies. So based on that, we can get the RAM. Okay, minimum is 128 GB. It's not like the 2 GB, 3 GB, 4 GB. So minimum we require the 128 GB RAM is required to install the HANA database. Okay, that's why in the outside you cannot practice the HANA database. Why? Because that much of RAM, they cannot bear that much of cost. The people they will bear it, but so we cannot. So some people, but we can practice it in our classes. We can practice on the HANA databases, not a problem. Okay, CPUs. So how to get how many CPUs you required based upon the RAM size. So each CPU, each physical CPU, this is the physical calculations. Each physical CPU, in the CPU, we have the two types, physical CPU and virtual CPU. If it is the cloud-based, you are using the cloud-based so platform, you have the clouds also. In the cloud-based, not the on-premises and cloud. If you are using the cloud-based platform, your CPU calculations vary. It may vary the CPU. The difference is different. If it is the physical CPU, so minimum, so 14 GB of RAM memory it will handle 14 GB of RAM memory. So which means one CPU it will handle the 14 GB of RAM memory. So okay, so 28 GB. If you have the RAM size is 28 GB, then two CPUs are required. If it is the so then if it is the so 14, right? 14 GB. One CPU will handle the 14 GB of RAM memory. Two CPUs will handle the 28 GB of RAM memory. Suppose you got the RAM size like suppose 256 GB, you got the RAM size 256 GB RAM size. Then 256 by 256 by 14. Then how many you will get? Calculation. If you take the calculator, then 256 divided by 14, which means you got the 18 CPUs. For the 256 GB RAM, you need 18 for 256 GB RAM. For 256 GB RAM, you need 18 CPUs you required. Okay, then only it will handle that much of. There is a calculation. Okay, I have 256 GB RAM is there. I can take it 2 CPUs means you will get the CPU issues and everything. So the correct estimation is one CPU will handle the 14 GB of main memory. So we have 256 GB RAM. Suppose take example. Then you will get the 256 by 14. How much you will get? 18 CPUs you will get. 18 CPUs you required to install the HANA database. 18 CPUs you required to install the HANA database. Okay. Suppose you have the 1 terabyte RAM. So your seniors, your manager, your architect asked you to take 1 terabyte of the RAM for the HANA database. 1 terabyte. 1 terabyte RAM. Then 1 terabyte by 14 GB. Then 73 CPUs you required. 73 CPUs you required. 73 CPUs you required to install the HANA database. 73 CPUs you required. So that's the calculation of the physical CPU. But when I go to the cloud-based, these are the on-premises mechanism. On-premises means, so in our premises, we have the CPUs and memory. But nowadays, there is a cloud concepts. Cloud concept, right? Cloud concept. If we go to the cloud concept, physical CPU, they have changed it to the virtual CPU, vCPU, which means one physical CPU equal to virtual CPU, to virtual CPUs, which means, so cloud-based, one CPU will handle only, so two virtual CPU means two physical, so which means 7 GB only. One in the cloud-based, it will handle the only 7 GB main memory only, it will handle it. So one virtual CPU will handle the only 7 GB 7 GB RAM memory only, it will handle it. So which means, so here 2 we required for the handle the 28 GB RAM, means here 4 we required. In the cloud side, we required the 4 virtual CPUs you required here. So you have to calculate this formula. So one CPU will handle the, one physical CPU will handle the 14 GB of RAM memory. Here one virtual CPU will handle the 7 GB of RAM memory. Okay. So one virtual CPU equals to two physical CPUs equals to one physical CPU. They have divided one physical CPU. They have divided into two virtual CPUs. They have divided. So which means 7 GB plus 7 GB. So 14 GB. Okay. So here we required the double we required. Here 256 GB to handle it. Here we need 18 CPUs. But in the cloud side, you required the 36 CPUs you required. You required 36 CPUs you required to handle the cloud side. You have to handle the cloud side. So CPUs. Got it? Any confusion here regarding the CPUs and the memory? Any questions from anyone regarding the CPU calculation? Sir, why we are calculating only for HANA, not for the SAP? We have not discussed this much, right? Means SAP is not required this much. SAP is the application. So just it can be installed in the any operating systems. Minimum 8 GB RAM is required to install the HANA database, sorry, SAP. Then storage 200 GB plus storage is required. That's enough. That's enough to install the SAP. But HANA, we need to be careful, and because SAP also will storing the data into the HANA database. The database is very good. The basement is good. Definitely, application will work without any issues. So, but the basement is not very good. Then how can we assume our home and our buildings, our apartments will stay very long life, right? So we cannot assume, right? So same as like here, the basement means our database is very good. Then on top of we will install the applications, right? Then applications will work it out. So that's the reason. So you can say like, so this is the way we have to calculate the CPUs and memory. That's why we are discussing in detailed way. So hardware requirements for the HANA and everything we are discussing. Hardware requirements we are discussing for the HANA. So hardware requirements we are discussing. Otherwise, we can directly, okay, this is the OS, this is the RAM we required. Then directly we have to install it. Like that we can discuss. But this is the way we are discussing. Okay, you got the clarification, right? Tomorrow they may ask you, can you tell me I think you in the resume you mentioned like you have put like HANA installation you have done, right? Then what hardware requirements you have chosen for install the HANA database? then we're in the position to answer the question, right? That's why we are discussing about this hardware requirements and everything.
Sir, 14 GB is standard, sir.
Yeah, 14 to 16 GB they will use it. So 14 to 16, either you can take the 15 GB, 16 GB also, but 14 to 16 GB. In between, you need to calculate the one CPU, 14 GB. You can calculate it. You can take it 14 GB. One CPU 14 GB, two CPUs 28 GB, three CPUs 52. So like that, the 14th letter, that the 14th you have to remember that one. Or you have to choose suppose 256 RAM, 256 by 40. But the standard normal recommendations. So we follow actually in the organizations to install the database. Why? Because CPU RAM there is a calculations. RAM calculations we know there is a SAP standard tool we will use it or reset method. We got the RAM size or your managers or your architect will provide the RAM size. Okay. So you have to install the RAM, you have to install the HANA database, take the 512 GB RAM, then go ahead and install it. So you will provide the RAM size, then you can go ahead and install. But you got only RAM size. But how many CPUs we have, then we don't know. If they ask you how many CPUs we required for the 512 GB, then you can simply tell 512 GB by 14, how many we will get, that many CPUs we required for the RAM. Why? Because HANA, we are discussing about that. It's the on fly, we can make the decision. It's one of the faster database in the world. It's the one of the faster database in the, so as compared to the other databases. Fastest means we should require the more RAM. Why? Because so data is storing into the inside of the RAM, it is storing the data. And also CPUs also should support, right? So based upon the RAM size, we should adjust the CPUs also, we have to supply. Otherwise, we will get the CPU issues, very fast, slowness, we will get it out. So to get that much of faster functionality, we have to estimate the CPUs and the RAM. So as per SAP recommendations, we have to go with this one. Okay. Any questions or confusion here? We'll stop it here for today, because today, so I think new topic, right? You need to digest all these words and everything, RAM, CPU, taste, everything. So I will digest it. I will stop it here. So any questions here?
No, sir.
No, nothing. Just discuss. Just only get the information only here, only up to here. Tomorrow, how many file systems we required? What is the network? And what are the softwares we required? How to download the softwares? Then how to install the HANA database? So we will discuss. Okay.